God Equation by Michio Kaku, author. Summary: the God equation presents a factual approach to the theory of life, the inception of the universe, and how modern physics lay the foundation of all natural laws that govern the galaxies, the planets, and our home called Earth. What's fascinating about science is that it fascinates everyone. Why? Ever since humans started thinking about the universe, what life means, and how we came to life, a lot of questions have popped up. With them, many answers emerged, but there's still plenty of information that's in the dark, literally. The God Equation by Michio Kaku explains the nature of reality, how the laws of physics apply to the universe and implicitly, our little planet, and how equations can help us make sense of the world we live in. By synthesizing lifelong learnings from humanity's masterminds, the book manages to explain universal physics principles and the nature of life. Here are my 3 favorite lessons from the book. Newton proved that the laws of nature act equally in every space, in or out of our planet. The theory of everything states that there are 4 essential forces of the universe. While Einstein didn't believe in God in a literal way, he had his assumptions about deities. Let's take a deeper look at these lessons, starting with the first one. Here we go. Lesson 1. Gravity and other laws of physics act upon outer space and the Earth equally. Newton was one great thinker, quite ahead of his time, which earned him a well-deserved spot in history. While some of his assumptions regarding the speed of light proved to be less than accurate by Einstein, discovering gravity and other major laws of physics remain groundbreaking findings even today. Newton discovered gravity with his famous Apple experiment. Then, in 1666, he argued that both heavens and our planet were governed by the same universal laws. He named this invisible force that exists everywhere as gravity, and it acts equally upon the moon and the apples falling from trees. He also proposed a way of calculating gravity through mathematical equations. His remarkable discoveries laid the foundation for modern physics and helped humanity achieve greatness from then on. However, in 1910 Ernest Rutherford discovered that these laws don't apply to what's inside an atom. There, a microscopic world emerges, where completely new laws apply. These make up an entirely new field of study, namely quantum mechanics. One major difference between our world and the world inside atoms is that they function on probabilities, while ours we can accurately determine through equations. Lesson 2. The universe is made up of 4 essential forces that govern everything. All the masterminds of science discovered remarkable laws and truths about our universe, which ultimately led to one universal concept. The universe we know is made up of 4 core forces: gravity, electromagnetism, the strong force, and the weak force. Gravity is what Newton discovered centuries ago. Electromagnetism is a force that was first split into 2 separate ones, electricity and magnetism. However, Michael Faraday discovered that these 2 are interconnected and that you could transform one into the other. Then, there's a strong force that binds the atom's nuclei together, and the weak force, which makes decay occur. All these forces act differently and have diverse properties. Consequently, they all make up a bigger picture that scientists haven't yet discovered. What we did discover is the Standard Model. This model describes how the world works from a scientific point of view. Although it has plenty of gaps and doesn't include the gravitational force, it can accurately predict physical models and facts about the world. Lesson 3. Einstein's fascination with black holes and his view of God changes many people's perspectives. Einstein was one of humanity's top thinkers and scientists of all time. His groundbreaking discoveries, such as the theory of relativity, and his ideas about black holes, dark matter, and gravity, all laid the foundation for modern physics. His view of black holes was that everything coming in contact with one would be lost forever in the space-time frame that these gravitational holes pull. However, modern-day scientist Stephen Hawking dared to contradict him, saying that the remains of particles might be found in the universe. And that's how we discovered the Hawking radiation. This theory proves other hypotheses regarding quantum principles. However, there was one other opinion of Einstein's that shaped our views of the world. People were preoccupied with his view of God. While he didn't believe in a deity that oversees humanity's behaviors and actions, there must be a force that governs and sets the laws of physics in motion. This force was named the first mover in scientific terms, and it implies that something must have initiated all the actions of the universe, including the Big Bang. Was that God? That's a question scientists are yet to have an answer for.